To get a practical idea of how to create an end-to-end customer intimacy solution, we'll look at a fictitious retail banking scenario. As with any organization, this bank wants to do a better job identifying their ideal customers, growing lifetime value, and retaining the customer longer. The IBM SPSS product portfolio is able to accomplish all of these steps, starting with capturing customer data. With IBM SPSS data collection, you can create one survey and deploy it in any mode: paper, in-person, web, or phone. In this example, a phone rep is using data collection to gather important satisfaction data. To start, we've created a script, ensuring the survey is introduced the right way. Data collection can also deploy a survey in any language, depending on the needs of the surveyor and the respondent. Thankfully for me, we'll continue with this survey in English as opposed to Japanese. It's important to note as we kick off the survey that data collection is not only a tool for creating generic surveys. Data collection can ensure that the demographic information on file is accurate. By pulling information directly from the CRM database, the telephone rep can easily update information such as address, city, state, email address, etc. Once all information is verified and the phone rep is confident that the data is correct, these changes will be automatically sent back to the CRM system. With the data already pulled from the customer database, each survey can be customized based on the user profile. So a question could be asked like, "What bank do you most often visit?" and answers can be populated based on the closest branches to the person's home or work address. We continue with a number of questions, all intended to gather critical information regarding the respondent's feelings about how the bank is catering to their needs. By asking a specific series of satisfaction questions, data collection tabulates the results in real time and automatically sends alerts if a predetermined threshold of dissatisfied responses occurs. This alert can be sent in the form of a text message or an email. This example gives a salesperson all of the pertinent information they would need, such as contact details and response data that shows exactly where the dissatisfaction occurred. In addition to structured questions, data collection has the ability to collect unstructured, open-ended question data. This information can be fed into the IBM SPSS Text Analytics product and, through natural language processing, categorize responses for structured analysis. If for some reason the respondent isn't able to complete the entire survey in one sitting, the telephone rep can send them a URL link with a specific identification number to complete the survey at their convenience, picking up at the exact place they left off, thus eliminating the need to duplicate effort and ensure the survey is completed. Once we have collected the attitudinal data from the IBM SPSS data collection products, we combine that with the existing demographic and behavioral data that exists in the customer database and begin the analysis phase with the IBM SPSS statistics products. With our direct marketing application inside statistics, we segment the data in a number of different ways by examining profile information such as whether or not they have a retirement or investment account, gender, age, etc., and supplementing that with the attitudinal data from our survey. This will help identify the best customer or the one most likely to purchase a particular product, look at what the best performing postal codes are in terms of sales, or even compare the effectiveness of various marketing campaigns. In this example, we'll look at RFM analysis, or recency, frequency, and monetary value score. To do so, we'll select variables such as length of time as a customer, the number of transactions in a month, and the highest account balances. Of course, we'll need to add the ID variable as well. As a result, we generate our RFM analysis, which comes in two different parts. There's a graphical part, which is represented by a heat map, and there's also a part that's attached to the dataset. The heat map graphically depicts the best performing sectors, which is indicated by falling in the highest range of frequency and the highest range of recency, and the darkest shade of blue, which represents a large account balance. In interpreting this heat map, we can look at it two different ways. Obviously, the people in the 5-5 square with the dark blue are our ideal customers. We could also look at some of the lighter blue squares and examine how to grow those customers by intelligently recommending other interesting products. In the dataset itself, we see the recency, frequency, and monetary value numerically represented. and it all comes together to give us an overall RFM score. Based on this RFM score, we could decide to target a promotional offer to the people with a low recency score, but a high frequency and monetary value score. In order to further predict customer activity, we'll use our data mining product called IBM SPSS Modeler. As we open up Modeler, we can begin by building a simple model stream using a series of nodes that connect to the data we've been working with and assist us by manipulating that data to get the results we're looking for. The first thing we'll do is grab the data set that's a combination of all the work we've done so far. To review, this is the existing customer data from the customer database, the survey data from data collection, and the RFM score data resulting from statistics. In addition, we're adding one more historical data field called Have Left Bank. This field tells us whether or not the customer is currently active or if they defected to a competitor. It's done in hopes that we can build a model to predict why and when a customer might leave or stay. Next, we need to tell Modeler how to treat each of our variables. We can include a variable in our calculations if the data is necessary, or we can exclude a variable if that variable won't add any value to our analysis, like customer ID, for example. And of course, we need to tell Modeler what to predict on, or our target variable. In this case, our target variable will be Have Left Bank. One of Modeler's unique features is that you don't need to know what algorithm or modeling technique you need to use right off the bat. Instead, we can use what are called auto modelers. In this example, we'll use the auto classifier auto model. If you look closely, the auto classifier is comparing 9 different models or 9 different competitive techniques, keeping the top 3 performing models for use in building our predictive model. The same thing could be accomplished by running every algorithm we have available, but the auto classifier does it automatically, saving a significant amount of time. The results are depicted in the top right corner of the screen, displayed as that gold nugget or yellow diamond. At closer examination, we see 3 different techniques that are ranked according to accuracy percentage. In this case, we have a C50 model, which is actually a machine learning model. Because that one scored highest, we'll take a closer look. First of all, it tells us what variables are the most important in terms of predicting customer churn. We can contract or expand this to get a more pinpointed or broad view of the variables that are contributing to our model. Again, going a bit further, we see a long, relatively complex, yet easy to understand list of components. Essentially, this is giving us a complete customer profile of who will leave. Zooming in, we can see that the most likely customer to leave is someone with a bank account of less than $570, falls into our RFM ranking score group, number 4, is in the 18 to 30 age range, has a monetary value of a 1, 2, or 3, is a male, and has made more than 12 transactions. We can continue to build out these models to determine what customer is the best candidate for a particular upsell or cross-sell campaign, or who our ideal customer is. In each circumstance, we can then further model who's the most likely to respond to a particular campaign, again based on our historical data and on the dataset we've compiled. Now that we've captured the correct data and predicted our results, we need to deploy those results to the enterprise in a secure environment, ensuring people see only the relevant information to their job. This is done by using IBM SPSS collaboration and deployment services. What you'll see first here is a statistical dashboard, once again displaying the heat map from before in the upper right part of the screen. Since this is an interactive graph, you can drill down to see an actual report showing us a breakdown of our highest net worth customers broken down by gender and age. In the upper left corner, we see a stream plot that allows me to look at RFM scores by location. A drill down of this graph will show me specific results of our average RFM scores based on whether someone is living in an urban, suburban, or rural location. We can use this information to give us a good idea of where we're lacking in terms of servicing various locations and devise a plan to fix that problem. Another graph we can look at talks specifically about some of our most stable customers in terms of the length of time they've been a customer with our bank. Again, drilling down into the data, we can further examine who those customers are and what profiles they fall into. This is done to configure future customer acquisition marketing campaigns aimed directly at those profiles. So within the collaboration and deployment services framework, we have a very wide range of deployment options, all of which can stripe across the entire organization. Everyone has access to the specific data they desperately need in order to perform their varying tasks and requirements. This includes traditional analysts that are interested in creating the segmentation or the models, the business analysts who are interested in specific business problems, as well as the actual business managers. As we conclude this customer intimacy demo, we'll look at the newest product in our portfolio, IBM SPSS Decision Management 6, or DM6. DM6 brings predictive analytics to the business users, allowing them to leverage their business knowledge and combine it with the power of predictive modeling. The goal in this example is to again predict which customers are ideal for specific cross-sell and upsell offers, and which are in jeopardy of defecting. In each situation, defining campaigns to meet the needs of each individual user. As you can see, this process occurs in a few short steps and is all completely configurable through an easy-to-use graphical user interface. These steps include connecting to the appropriate data sources, selecting the customers we want to connect with, defining the campaigns we want to run, prioritizing objectives to optimize results, and finally, validating and deploying the configuration into production. As we begin with the data connection step, we have the option to connect to a variety of sources, including a database and other existing files. In this example, we'll once again connect to the same data sets we've been working with, our historical customer data, as well as our response data. The Global Selections tab allows us to specifically select which customers should be included or excluded in any one of our retention or cross-sell offers. In this case, we'll exclude two groups of customers, those that have had a bad payment history and those that have received an offer from us in the last 2 months. We can see how easy it is to build one of these rules. In the case of the second rule, we simply have to choose the correct variable, weeks since last offer, set that to be greater than 8, and select the exclude option. The Define tab gives us the capability to build the campaigns or offers we'll send to our customers. As you can see, we start off with a completely blank slate and can begin by naming each individual campaign, whether it's for our retention or our cross-sell offers. In an attempt to retain at-risk customers, we'll either offer theater or racing tickets. Our cross-sell efforts will include credit cards, home equity loans, and personal loans. Next, we define the customer profile for each campaign or offer. This process is very similar to the previous step in that we're leveraging the business knowledge gained through our analysis done using the statistics and modeler tools. For our retention campaigns, we'll include our high-value customers, defined by the number of months they've been a customer, and the number of products they've purchased from our bank. We'll further segment these offers by determining that females will receive theater tickets and males will receive racing tickets. The same process is followed for the cross-sell offers, but for the sake of time, we'll skip ahead in the video. By simulating the results of the campaigns based on our historical customer data, we can see that approximately 1,700 customers will receive cross-sell offers and 200 will receive retention offers. Out of the cross-sell campaigns, 248 will receive personal loan offers, 469 will receive home equity loan offers, and 982 will receive credit card offers. For our retention campaigns, 92 customers will receive racing tickets, and approximately 109 will receive theater tickets. The Prioritize tab further validates the campaign recipients by merging the previous business rules with current campaign knowledge, such as the cost of execution and predictive models to identify the appropriate action to take. As we see in this example, we're creating a predictive model to determine which customers are the most likely to select theater tickets. So instead of sending everyone tickets just because they fit into our generic profile, we're selecting only the customers most likely to respond, thus cutting down on the overall campaign cost. Finally, formulas combine expected revenue, campaign costs, and probability to respond in order to select the optimal recommended offer based on the financial interests of our company. Before deploying this into configuration, we can run a what-if scenario to see how our business rules and predictive models would have done if they were applied to our historical customer data, where we know the outcome of the interaction. If we decide we're not happy with the outcomes, we can change some of our settings and run the configuration again and again until we are satisfied. In the last step, there's one last piece of customization we can do. If we happen to notice that there's a piece of information we're commonly missing, or is crucial to building our predictive models, we can script questions for our customer service or sales reps to ask while they're interacting with that customer. The answer will not only be incorporated into the decision-making process, but it will also be updated in the customer database for future reference. Finally, we're ready to deploy our decision management configuration. We have the option to deploy a testing, pre-production, or live environment for further analysis to begin interacting with the live customers through our enterprise. The idea of a customer-centric strategy accomplished by incorporating an end-to-end customer intimacy solution is not a fantasy. By leveraging the complete IBM SPSS predictive analytics family portfolio, you can successfully and easily empower your point of interaction employees to make optimized decisions to ensure optimal results. Smarter customers require smarter interactions, and smarter interactions demand smarter tools. This is IBM. Welcome to the Decade of Smart.